Good morning, everyone. Today I'm here to talk about Etherlink, and more specifically, I'm here to talk about how we are scaling Etherlink without making any compromise. And before I dive too much into the details of the talk, I think it's a good idea to start with the beginning, and the beginning here is probably to say, what is Etherlink? In a nutshell, if we keep to the essence of what Etherlink is, it's the EVM compatible layer of the Tezos. And if we dig a little more, how we have implemented that, it's a layer 2 blockchain that is built on top of optimistic rollup, but that's implementation details. What we wanted to do with Etherlink, first and foremost, was to bring EVM compatibility to the Tezos ecosystem at a time where it could make a difference. Now it's still a layer 2 blockchain, and we want it to be attractive. And the fact is, as speakers at HCC, for instance, put it, we have a layer 2 blockchains that are started every day. Maybe there is one today, maybe there is one tomorrow. So we need to bring something to the table that others don't. So we built Etherlink with three main concepts, three main core values in mind. We wanted Etherlink to be fast, fair, and nearly free. So fast today means that the sequencer is creating blocks every 500 milliseconds. So you have to wait a bit around that time to get a confirmation that your transaction is included. And this unlocks some use cases, typically in DeFi, where having a low latency is important. It's nearly free in the sense that it doesn't cost a lot to include a transaction on chain. Right now, a transfer of Tez on Etherlink is around a tenth of a cent, which is pretty competitive among in the space. And this is necessary. If we want Etherlink to be a place where you can have a wide range of use cases, we need to take into account the use cases that requires to send a lot of transactions. And if you have a transaction that you send once that costs 20 cents, it's okay. If you have thousands and thousands of transactions to send every day, which we have already some partners doing on Etherlink, this is prohibitive. So 1/10 of a cent for a transfer is where we are right now. And potentially most importantly, and I think this is here that we have maybe a bit of advance on the competition, is that we want Etherlink to be a fair platform. And what we mean by fair is that we don't have a set of people, a set of third parties that have particular rights on Etherlink. Etherlink is a permissionless platform that is open. So typically the governance of Etherlink has been entrusted to Tezos bakers, which is a permissionless set of people. Anybody can become a baker, and anybody can start engaging with Etherlink governance, the same way you can engage with the Tezos governance, Tezos layer 1 governance. Bakers vote for two things. They vote for the upgrades, and they vote for the identity of the sequencer, which at the end of the day, when you have this kind of infrastructure in place, gives you a non-custodial rollup where there is no hidden keys, there is no multisig. It's a permissionless system without an admin backdoor. And we've been building Etherlink for a while now, and it's turned out that July, for some reason, I don't know if you can guess why, is a pretty active month. So to give an example of what the retrospective, in 2023, we announced Etherlink as publicly at HCC and TezDev, and the testnet started at that time. So we had a testnet on Etherlink for 2 years now. 1 year later, we already had the mainnet. It was in a beta stage at the time. It's no longer the case. And the mainnet was live, and it was already non-custodial from day one. And I think it was a very important commitment for us to get this approach a bit different than what the rest of the ecosystem is doing, where they build a rollup first and then they gradually make it non-custodial. In our case, we decided that Etherlink needed to be non-custodial from day one for the guarantees that it provides. It's not like you need to trust us that we will keep working on decentralizing Etherlink. It's already there, and it's here to stay. Over the course of the year, of course, we didn't stop. And July, again, is a busy month for Etherlink, especially if you are a baker, because it's voting month. We have 2 proposals for bakers to vote. And one in particular, and I mentioned that because it's actually a good transition for the topic of the talk, is that we are proposing an upgrade that changes a little how the gas price works and how the gas price is computed to align it better with the capacity of Etherlink today. we were a bit conservative, to be honest, on what was the capacity of Etherlink, and it turns out that when testing more and more thoroughly, we noticed that actually we had some room of improvement, so the upgrade that we are proposing fixes that. And it's important because you don't want to have the gas price increasing for bad reason. But I wouldn't say personally that we are happy with the capacity of Etherlink today. It's enough for the current activity of the chain. The gas price on Etherlink doesn't change at all, but it's not enough for the kind of ambitions that we are having for Etherlink in particular and Tezos X as a whole. So we have a commitment in the short term to increase the capacity of Etherlink at least tenfold. In other words, for programmers here that might ring the bell, we want to make Etherlink blazing fast in the next 6 months. And now let's ask the question of how do we do that? And there is two aspects to consider. The first one is to execute transaction faster. You have a transaction, you want to spend as less time as possible executing it. And here we have plans, very concrete plans to increase the throughput of Etherlink, to increase the speed at which the transactions are executed. I gave a few examples here. We are not particularly happy with the MVM implementations that we are using. We want to change it. It's a very active project that is making great progress, and we already have a very promising benchmark on how this will improve the overall speed of Etherlink. But this will not be enough. We need to go even beyond that. We want to introduce parallel execution where it matters. It's a hot topic in the industry. This is something that we can work on as well and that we can leverage. Again, even with that, it's probably not enough. We have some concern about not concern, but like we know some limitation of the current runtime that we are using for smart rollups. And fortunately, it's something that we noticed a while back, and we have a team that is working actively on bringing us a new runtime for smart rollups, one that is using RISC-V, and there is a talk just after me about that. But I'm mentioning it because it will bring a storage backend that is particularly, like that has been designed, implemented, optimized with the optimistic rollup use case in mind, and that will be particularly well suited to improve the performances of the system. So if you put that all together and you add a few more optimization in the bunch, then we will be able to process transaction faster. But then there is another issue, like just processing the transactions that we already have faster, we'll have, like, you get a more responsive system, for instance. But what we really want is to increase the capacity of Etherlink. We want to increase the activity, or we want you to increase the activity of Etherlink, and we want to be one step ahead and always be ready for the activities that you bring. And to do that, we need to consider the amount of transactions that you will bring. Potentially, we already have hundreds of thousands of transactions every day. Potentially, we'll have 1 million of transactions every day with Etherlink and with Tezos X. And we need to get ready for that. And I mentioned that we are an optimistic rollup. It's an implementation details as far as you are concerned, but at the same time, it's important because it dictates a bit what we need to do for it to work. And in particular, for an optimistic rollup to work, we need to publish the transaction of Etherlink somewhere. And we need this publication to be available for everyone. Right now, we are using Tezos Layer 1 blocks, but sadly, they are a scarce resource. Just to give you a few numbers, it's like 500 kilobytes every 8 seconds today. We can increase the block size, we can reduce the block time, but at the end of the day, the order of magnitude of Tezos Layer 1 block won't be enough. And this is potentially a concern because of when you consider scaling without compromise, you need to keep in mind what it means to increase both the speed of your system and the amount of data that you are transmitting. Processing more transactions faster, it's an optimization challenge. It's a hard one, but ultimately it's about using the hardware that we have at our disposal in a more clever way. But processing more transactions means publishing more transactions. And here we are potentially hitting a bar, or at least we would have if we didn't plan accordingly. Because if we start publishing on the transaction, on Tezos Layer 1 and start publishing elsewhere, then the question is, what is the elsewhere and what it means? For instance, we could have used the data availability committee. We could have entrusted to a set of trusted partners the ability to, or the role to make the data available. But would we be a decentralized, non-custodial rollup if we do that? The answer is no. because a rollup, at the end of the day, has a one honest node assumption where you need someone, and it needs to be anyone. You don't to be able to be here, to care about the Etherlink, to compute the state and to protect it. But they cannot do that if the transactions are not available. So really the processing more transactions quickly become a security challenge. And we knew that in 2021 or 2022, I don't exactly recall when it started, and we start building ahead of time to address these particular challenges. And the result of this work is what we call the data availability layer, the DAL of the Tezos layer 1, which is already up and running on the mainnet. And it's what we call the rollup booster, because the goal of the DAL ultimately is to increase the bandwidth of the data that you can provide. So in a nutshell, the DAL, it's a proof of publication system. You send some data to a peer-to-peer network, you get an attestation that it's been published. This peer-to-peer network is open, permissionless, and so you get the decentralization that you want to have. The same way we have enshrined to the Tezos layer 1 protocol the smart rollups, we have decided to enshrine to the Tezos consensus directly the DAL, and the set of parties that are attesting the publication of data, they are the same ones that are participating in the consensus of Tezos, that is the bakers, and we can actually be thank them and be very enthusiastic by the fact that today DAL is run by more than 85% of the baking power of Tezos layer 1, and that it's been live since May. So DAL is already here today for Etherlink to use to increase its capacity. And we also prepare in advance on the Etherlink side. Since Dionysus, which is the current version of Etherlink, you already can, the sequencer actually, can publish transaction to the DAL. It's not doing it right now because there is an impact on the latency of the bridges today. So we'd rather start doing that when we did it. But as soon as we need it, or even before, because we don't want to bring conjunction to the Tezos layer 1, we'll be able to enjoy this additional capacity. And we will do that in a way where there is no loss of decentralization and where the core values of Etherlink remains true, and in particular that it remains a fair, non-custodial rollup. So if you've been following Tezos news and the core development, the work of core teams that are working on Tezos today, it's an exciting time to be in like 2025, because it's a time where it's all coming together. Like we've been working on, I think the roadmap of Tezos with respect to scaling has been published in 2021 or 2022. We've been working on layer 2 technology for 4 years. We have smart rollups, we have the DAL, we have Etherlink, and everything is in production and everything works in a decentralized way. So July 2024 to July 2025, at least for the people working on Etherlink at large, it was really about bootstrapping the CVM compatible layer for Tezos. And I want to state very clearly that it's a lot of work. Like launching the chain, that's the easy part. Having the chain being used, having an ecosystem that is in place, having the tooling, having the partners, having the projects landing, that's the hard part. And this was really the focus on 2020 of this year. It was really important for the experience that you get on Etherlink to be as seamless as possible and as comfortable as possible. It's done in a context where everything is done for 10 seconds and then something new happens and you need to catch up, or you need to participate to the discussion about the future. It's not only about catching up, but at the very least right now, Etherlink is a welcoming chain and one that is very well suited for a wide range of use cases. And now it's about preparing for the future and actively building it. I mentioned going full throttle in terms of performances. This is really the focus of the teams for the next months. And this additional capacities that we are creating by doing that, we wanted to be here for creating more room for more users, more builders, more use cases, and more technologies. And I will stop there about that because it's more in the Tezos X territories and the Etherlink today. And there is a talk from Arthur about the product roadmap of Tezos X. But in the meantime, just know that Etherlink is already here. It's already welcoming for you. And if you have any question about the state of the chain or the short-term plans that we are having, and even the longer plans, feel free to ask. I think we have a bit more time for questions, so I'd be happy to answer them. Thank you.
Do we have any questions for Thomas?
You don't have to force it, but but I'm happy to answer if you have.
Hello?
Hello?
Hello? Okay. Is it already possible to mint NFTs on Etherlink?
So Etherlink is already a fully working AVM compatible chain. So anything you can do on, I don't know, a chain like Ethereum, Arbitrum, and things like that, you can do on Etherlink. We have all the tools. We have the infrastructure in place now. We have partners. Yeah, the short answer is yes. And the long answer is you can mint that low level with a contract of your own, or you can use, typically, for instance, we have Sequence, that is a marketplace for NFTs, or meta marketplace of NFTs that you can use directly. So yes, you can.
Merci.
I think.
Thanks, Thomas, and for the team at Nomadic Lab to do the...
And Trilitech.
And Trilitech to do the big work.
Sorry.
The big work over the past few years. I think it's important to connect our very tiny community to new user. I'm just curious about your opinion about the recent announcement and the willingness from big player in the market to use sovereign layer 1 EVM solution, and how you see the future of Etherlink in this context.
So, to be honest, it's a bit outside of my domain of expertise, but to try and answer under the control of more knowledgeable person, I think Etherlink in isolation is a nice product, but the competition is wide. Like we have a huge space. As I mentioned, like we have a lot of projects that are happening. And Etherlink alone, while, again, it's interesting to deploy on, we'll have a rough competition. I think where we can bring more users in the long term is more about the Tezos X roadmap, where Etherlink doesn't disappear. It remains it keeps its advantages and what we've built already, but it can also leverage a huge ecosystem that Arthur will present. So maybe I'm dropping the ball, I don't know, but I think it's more about what we are building here is the first step towards something bigger that I think will be of interest for the ecosystem at large. But the journey is not over, basically.